Hello there, John with Gringo.dev reporting live from Mexico City, Mexico, and tonight I have a treat for everybody. I wanted to review the essay over here called Choose Boring Technology. It's actually one of my favorite essays in tech anyway, pretty much of all time. And anytime that I'm evaluating a company to invest, or the CTO wants some advice, or I'm somehow going to be involved, one of the things I request is that the CTO, or really anybody in leadership who has to concern themselves with technology, read this essay. That's actually how influential it has been on me. So I'm going to do my best to get out of the way and let the piece speak for itself, as it were, and just give my comments here and there, just to add some color. But let's get into it. So, Choose Boring Technology by Dan McKinley. Dan was a senior technical person at Etsy for quite a few years, I believe, and obviously was in a position to make a lot of choices about the technologies that they allowed into their stack. And so here he goes. Probably the best thing to happen to me in my career was having had Kellen placed in charge of me. I stuck around long enough to see Kellen's technical decision-making start to bear fruit. I learned a great deal from this, but I also learned a great deal as a result of this. I would not have been free to become the engineer that wrote data-driven products now if Kellen had not been there to so thoroughly stick the landing on technology choices. In the years since leaving Etsy, I've resurrected my ability to care about technology, and my thoughts have crystallized to the point where I can write them down coherently. What follows is a distillation of the Kellen Gestalt, which will hopefully serve to horrify him only slightly. And only color that I'll add here is just that, having those senior technical mentors is just such an important thing. And it's hard to overstate the importance of just having seen how a lot of tech choices turn out. One point that I always found kind of interesting is it seems like the more experienced somebody is with technology, it's almost like the less they care about the particular choice. I mean, a very common attitude is just like whatever. It's as long as it's a reasonable choice, like you can accomplish most things with most things. It's pretty uncommon to find, a Node.js chauvinist, for example, among people who have been coding for like 20 years, at least professionally or at a high level, So just when in doubt, talk to somebody. I think that's an important point. But moving on, embrace boredom. Let's say every company gets about 3 innovation tokens. I love this frame. You can spend these however you want, but the supply is fixed for a long while. You might get a few more after you achieve a certain level of stability and maturity, but the general tendency is to overestimate the contents of your wallet. Clearly, this model is approximate, but I think it helps. If you choose to write your website in Node.js, you just spent one of your innovation tokens. If you choose to use MongoDB, you just spent one of your innovation tokens. If you choose to use service discovery tech that's existed for a year or less, you just spent one of your innovation tokens. If you choose to write your own database, oh God, you're in trouble. And so I'll stop here for a second. It's kind of funny because this was written in 2015, I believe. And I would still say in some ways that with some of these technology, like especially Mongo, you are still, in, I would argue, spending an innovation token. Maybe for different reasons, not because it's like super new or whatever, but I've ranted about that before and why you should almost always be using a relational DB, assuming you can. But the basic idea here is that you have a budget. That's kind of a way to think about it. And so you have a budget for innovation. I think a lot of people get in trouble because they don't realize that they have a budget and therefore behave like that budget is infinite. And so the degenerate case, let's say, of that is something along the lines of hottest new tech for the front end, hottest new tech for the back end, hottest new tech for the database, and so on and so forth, even though the focus of your business is something completely different, right? And I think he's going to go on to say this, but maybe I'll spoil it a little bit here. The basic idea here is that if you have a fixed budget of innovation to spend, it's probably best to spend it on the areas where you're actually innovating, right? So any of these choices might be sensible if you're a JavaScript consultancy or a database company, but you're probably not. You're probably working for a company that is at least ostensibly rethinking global commerce or reinventing payments on the web or pursuing some other suitably epic mission. In that context, devoting any of your limited attention to innovating SSH is an excellent way to fail, or at best, delay success. What counts as boring? That's a little tricky. Boring should not be conflated with bad. There is technology out there that is both boring and bad. You should not use any of that. But there are many choices of technology that are boring and good, or at least good enough. MySQL is boring. Postgres is boring. PHP is boring. Python is boring. Memcached is boring. Squid is boring. Cron is boring. And yeah, so I mean, this list has probably grown since it was written in 2015, but I think it still holds, right? And it's actually kind of a testament to the point of this entire thesis, which is, MySQL was boring in 2015. It still exists. It's boring today. Today, same goes for Postgres. Same goes for PHP and Python and all the rest, right? And so that's kind of the idea here. Like, you don't want to end up saddled with some technology where, it's hot for a hot minute, let's say, and then, in 5 years it's gone and you're left picking up the pieces. The nice thing about boringness so constrained is that the capabilities of these things are well understood. But more importantly, their failure modes are well understood. This is a very good point. Anyone who knows me well will understand that it's only with an overwhelming sense of malaise that I now invoke the specter of Don Rumsfeld, but I must. When choosing technology, you have both known unknowns and unknown unknowns. A known unknown is something like, we don't know what happens when this database hits 100% CPU. An unknown unknown is something like, geez, it didn't even occur to us that writing stats would cause GC pauses. Both sets are typically non-empty, even for tech that's existed for decades. But for shiny new technology, the magnitude of unknown unknowns is significantly larger, and this is important. So just to explain the reference here for viewers who are not American. So Donald Rumsfeld was the Secretary of Defense, I believe, during the second Bush presidency, and used these terms, known unknown and unknown unknown, to describe the situation that was deteriorating in Iraq, if I remember correctly. And so he said something to the effect of, I think as an excuse, although I don't remember all the history, something like, there were things that we knew that we didn't know going in, and there are things that we just kind of discovered after the fact that became apparent. And so the idea of, knowing that you don't know something versus just being completely surprised that you don't know something. And that applies to technology too. So there's all sorts of stuff. I mean, it just takes time for tech to bake. That's the truth. And so, I think the basic idea here is that if you are doing something truly innovative in a certain space, be it AI, ML, any number of other things, right? Like you have a mission, whatever that is, probably you shouldn't be innovating on the basic HTTP request response cycle, right? There are plenty of technologies that do that perfectly well. Same with displaying a web page to the end user. Same with a bunch of things, databases, all of that stuff, right? Like the tech exists. So like there's no need to get cute with it because the number of things that you don't even know that you don't even know is actually going to be very large in all likelihood. Versus, let's say, an old technology like MySQL, been around forever. And sure, it's not perfect. No tech is, right? But like all of the warts are basically out in the open. And if you hit some corner case, chances are you're not the first one, and somebody out there has already figured out a workaround or something. Optimize globally. I unapologetically think a bias in favor of boring technology is a good thing, but it's not the only factor that needs to be considered. Technology choices don't happen in isolation. They have a scope that touches your entire team, organization, and the system that emerges from the sum total of your choices. Adding technology to your company comes with a cost. As an abstract statement, this is obvious. If we're already using Ruby, adding Python to the mix doesn't feel sensible because the resulting complexity would outweigh Python's marginal utility. But somehow, when we're talking about Python and Scala or MySQL and Redis, people lose their minds, discard all constraints, and start raving about using the best tool for the job. Your function, in a nutshell, is to map business problems onto a solution space that involves choices of software. If the choices of software were truly without baggage, you could indeed pick a whole mess of locally the best tools for your assortment of problems, which would look something like this. But of course, the baggage exists. We call the baggage operations and to a lesser extent cognitive overhead. You have to monitor the thing. You have to figure out unit tests. You need to know the first thing about it to hack on it. You need a init script. I could go on for days here, and all of this adds up fast. The problem with best tool for the job thinking is that it takes a myopic view of the words best and job. Your job is keeping the company in business, and the best tool is the one that occupies the least worst position for as many of your problems as possible. It is basically always the case that the long-term costs of keeping a system working reliably vastly exceed any inconveniences you encounter while building it. Mature and productive developers understand this. So yeah, there's a lot to unpack here, but I think the first thing is just kind of obviously true if you've been writing software for a while, which is the overall cost in shipping something is actually much, much, much higher than just writing the code. And in fact, the actual writing of the code is kind of a minority of that life cycle, right? Like, so you probably did some sort of design before you actually started writing code, even if it was just you. If you're on a team, maybe you had some meetings about it, then you implement it, then you probably test it. Then there's hopefully test automation to ensure that it doesn't break. Then you have to go and deploy that. That may or may not involve some new topology for your production infrastructure, then monitoring that system and so on and so forth. And so actually like the writing of code, sitting down and typing out the code is very likely a small part of the actual cost in this. And that's an important point, right? And I think it's underestimated. Like we tend to focus a lot on the coding aspect of stuff because that's what we do and probably what we enjoy. But, in reality, most of the work is somewhere else. And, I think that kind of to the points that were made earlier, if you understand, a system really deeply, or people on your team do, warts and all, it's going to become much easier to ship something when you can just lean on that expertise in house. You can lean on the systems that already exist. You can lean on the monitoring and like all of this stuff. You might actually say, well, hey, I think the example was Ruby versus Python. So like Ruby, for example, might be a slightly better fit for the problem that we're trying to solve. Like maybe it's a more elegant way of having a DSL or something in your code and like it's cleaner or you just like it better, like whatever. But the truth is like probably 90% of what it can do can overlap with what Python does, right? So even if you don't like Python that much, if your team is already delivering Python code in prod, there's a good chance that it's just better to use Python for the thing, right? And so the case where you deviate from that is when there's truly a unique capability at play here. And I think he's going to get to this for a second, so I won't talk about it too much. But the idea would be something like, I want to do, let's say I have PHP on the front end, so classic request response cycle, and I want to do some sort of like real-time messaging in between my users, right? So like that's where PHP is probably not a good fit, right? And you might want to use something like Node or Golang or Elixir or something with better concurrency, right? So that's the whole idea of mapping your problems onto technical solutions. Like if you don't have a destination to map something to, then by all means you should add a point in this second little circle here, or ellipse, I guess. But yeah, so I think that's the basic idea here. Now, choose new technology sometimes. Taking this reasoning to its reductio ad absurdum would mean picking Java and then trying to implement a website without using anything else at all. And that would be crazy. You need some means to add things to your toolbox. An important first step is to acknowledge that this is a process and a conversation. New tech eventually has company-wide effects, so adding tech is a decision that requires company-wide visibility. Your organizational specifics may force the conversation, or they may facilitate developers adding new databases and queues without talking to anyone. One way or another, you have to set cultural expectations that this is something we all talk about. One of the most worthwhile exercises I recommend here is to consider how you would solve your immediate problem without adding anything new. First, posing this question should detect the situation where the problem is that someone really wants to use the technology. If that is the case, you should immediately abort. I completely agree with that, by the way. Like, I don't know. Like, I understand that people have their preferences in programming languages and like whatever tech stack, but it's just most of the time you can achieve most things with most tools, with some of the exceptions I talked about earlier. So, be on high alert for that sort of thing and resist if it seems to be coming from a place of, I just turn my nose up at a certain tech and I don't want to deal with it, even though it's the default at the company or whatever. It can be amazing how far a small set of technology choices can go. The answer to this question in practice is almost never, we can't do it. It's usually just somewhere on the spectrum of, well, we could do it, but it would be too hard. If you think you can't accomplish your goals with what you've got now, you are probably just not thinking creatively enough. It's helpful to write down exactly what it is about the current tech stack that makes solving the problem prohibitively expensive and difficult. This is related to the previous exercise, but it's subtly different. New technology choices might be purely additive. For example, we don't have caching yet, so let's add memcache. But they might also overlap or replace things you are already using. If that's the case, you should set clear expectations about migrating old functionality to the new system. The policy should typically be we're committed to migrating with a proposed timeline. The intention of this step is to keep wreckage at manageable levels and to avoid proliferating locally optimal solutions. This process is not daunting and it's not much of a hassle. It's a handful of questions to fill out as homework, followed by a meeting to talk about it. I think that if a new technology or a new service to be created on your infra can pass through this gauntlet unscathed, adding it is fine. So yeah, I think that's a slightly different twist than what I was just saying, but you should be asking the questions like, what does this technology enable that I need that I cannot do with the existing technology? And hopefully that's not an empty list, right? And then assuming that you get past that, then you should also ask, well, if there is overlap, what are we going to do with the old system if we truly want to migrate? And, I do like this idea here of, the intellectual honesty. We're not going to sort of pretend that these two things are going to live side by side forever. Like we're making a commitment that we're going to move, and maybe it doesn't have to be tomorrow, but we're all on the same page that it's going to happen. And so I think like a lot of things, just having a conversation is actually a great tool for making sure that you're at least being deliberate about these decisions. Like kind of to the original point about having a wallet that you don't even know exists, a budget that you don't even know exists. The ignorance of self is one of the biggest dangers, right? And so if you're not being honest with yourself or your team, even if it's unintentional, it's just sort of like coming from a good place or whatever, but oh yeah, we'll totally move off at some point, but maybe you're not serious about it, or like all of those things. Like just being very clear with yourself above all, but like also the people on your team about like what the expectations are for like moving off, consolidating, like all of that stuff. I think it's a very healthy thing to do. Like I think that allowing that stuff to just happen in darkness without being talked about is kind of the origin of a lot of problems. So I agree with that. Like I'll probably sum this up at the end a little bit too, but like I think the one case where something like this is just not going to apply too much is like if for whatever reason you've reached the scale where you need a lot of teams that can move very independently, like I actually think all of this reasoning still applies, but it's just going to be kind of like recursively applied down to the team level, right? So among my unit, however large that is, maybe I want to be asking these same questions and making decisions accordingly. But maybe it's not appropriate if you have 200 individual teams. Every company calls them something different, whether it's a squad or whatever. But if you have like 200 of those and they all want to move independently, having to sit down the entire engineering team, which might be thousands of people, to make these sorts of discussions about trade-offs is probably just not practical, because the whole reason you organize your company that way is so that you're loosely coupled and can move more or less independently, right? But I don't think that's the situation he's talking about here. It's more of a unified engineering org that's pretty likely working on out of something that looks more like a monolith. So in summary, just ship. Polyglot programming is sold with the promise that letting developers choose their own tools with complete freedom will make them more effective at solving problems. This is a naive definition of the problems at best and motivated reasoning at worst. The weight of day-to-day operational toil this creates crushes you to death. Mindful choice of technology gives engineering minds real freedom, the freedom to contemplate bigger questions. Technology for its own sake is snake oil. So yeah, hopefully you can see why this is one of my favorite essays. So just my closing thoughts on it. Obviously, this resonates with me quite a bit because I spend a lot of my time talking about technology that is far from sexy. And I love it. Why? Because I don't see my job as playing with the hottest new thing. I see my job as being, well, really my passion too, as being solving real problems in the world. And so it is fun to play with stuff, don't get me wrong. But like when it comes time to get serious, I'm going to use tools that are well understood, that more importantly, I understand deeply, and, I'm not going to add tech to a stack just for the sake of playing with something. Like I don't think that's a good decision in the vast majority of cases. Now, the exceptions to that are going to be things where, it really is sort of in the current of your innovation path, right? So by all means, if you're doing some crazy AI or ML stuff, like it's okay to go and try out like the latest Python packages if it's in the furtherance of the actual mission of what you're doing, right? And so you have to be careful about that stuff. I think the closing or second to last sentence in the piece here is important. Like, look at the first word, mindful, right? So the whole idea here is that you should be consciously, deliberately making decisions, and don't just choose things because it sounds cool or whatever. Because you might think you're in control of those decisions, but I think more often than not, that's the result of marketing or just groupthink or whatever it is. And like all of us are susceptible to that, myself included. So you know, give this essay a read. I'm going to leave the link in the description. Like I said, depending on the stage of your company and how it's structured, maybe it applies more or less. But I think for, let's call it like medium or smaller teams, maybe up to like several hundred engineers, especially if they're working out of a monolith, this is probably a very good way to approach tech decision making. If that doesn't map so cleanly onto your team, like even if you just have like a team of 20 people below you or something like that, I still think it's worth thinking about this because like the problems of having so many different things you have to support and understand and like all of this stuff, that applies to your team, even if it's a small part of a much larger whole, right? So anyway, link will be in the description. I hope this was helpful. If you liked it, please like, please subscribe, and I will see you guys next time. Take care.